All right, let's take a look at the clicker questions for Chapter 3, the normal distributions. Which one of the following is a false statement about density curves? It's true, they're always on or above the x-axis. The area under the curve within the interval is the proportion of values expected in that interval. True. Total area under the curve depends on the shape of the curve. False. The area under the curve always equals 1. The curve is an idealized depiction of the distribution of a variable. The false answer is C. The area under the curve is always 1. Which of the following is a false statement about density curves? It's false that the mean and the median are always the same. That's only true if the density curve is symmetric. If you know that mu equals 0 and sigma equals 3, which density curve applies? Density curve 2 has the spread that we're looking for. 3 standard deviations on either side gets us to -9 to 9. And you can see that there's data on data set 2 representing information from -9 to 9. There's no area under the curve on data set 1, starting at about the first standard deviation away from the mean. Here is a density curve as a model for the distribution of spoilage times of a packaged product. Is the mean spoilage time smaller than the median spoilage time? The mean spoilage time is not smaller than the median spoilage time because the mean is pulled into the tail, and being pulled into the tail means that the mean spoilage time is more weeks than the median spoilage time. Here is a normal density curve as a model for the distribution of birth weights for full-term babies in the United States. True or false? Baby Emma, who weighed 4,350 grams at birth, was larger than half of newborn babies. This statement is true. You can see the halfway mark is at about the 3,500 gram mark. Here is the same normal density curve. The median full-term birth weight is told to us to be 3,485 grams. What is the mean full-term birth weight? In this example, the mean will be equal to the median because of the symmetric distribution. Attendance at a university's basketball games follow a normal distribution with mu equal to 8,000 and standard deviation sigma equal to 1,000. Estimate the percent of games that have between 7,000 and 9,000. Since 7,000 to 9,000 is between 1 standard deviation below and 1 standard deviation above the mean, we have 68% of the data. SAT scores follow a normal distribution with mean mu equal to 500 and standard deviation sigma equal to 100. Estimate the percent of SAT scores that have between 300 and 700 points. 300 to 700 points is 2 standard deviations below and above the mean, which means we have covered 95% of the data. Here we are with birth weights of full-term babies in the United States approximately follow the normal distribution with mu equal to 3,485 and sigma equal to 425. What percent of full-term babies have weights greater than 2,635? So if we take 3,485, subtract 1 standard deviation, that's not low enough, subtract another standard deviation. If we subtract 2 standard deviations, we get to the value 2,635. So to see what percent of full-term babies have weights greater than 2 standard deviations below the mean, we know by the 68, 95, 99.7 rule that we'll have a minimum of 95, and we won't be more than 99. So as a result, we can trap ourselves into the 97.5%. Which of the following is a false statement about the normal distribution? It is false that the mean is greater than the mean. In a normal distribution, we have a symmetric, bell-shaped, unimodal distribution. All normal distributions satisfy the 68, 95, 99.7 rule, which describes what percent of observations lie within 1, 2, and 5 standard deviations of the mean respectively. That's false. It is between 1, 2, and 3 standard deviations of the mean respectively. Which one of the following is a true statement about the standard normal distribution? The only true statement is statement A, that the standard normal distribution is the normal distribution denoted capital N 0, 1, which means a normal distribution with mean 0 and standard deviation 1. Suppose the lengths of sport utility vehicles, SUVs, are normally distributed with the mean mu equals 190 inches and the standard deviation sigma equal to 5 inches. Marshall just bought a brand new SUV that is 194.5 inches long, and he is interested in knowing what percent of SUVs is longer than his. Using his statistical knowledge, he drew a normal curve and labeled the appropriate area of interest. Which picture best represents what Marshall drew? Plot B represents what Marshall drew because Marshall is looking for the amount of observations longer than his own observation of 194.5. So we point to the area under the curve that is to the right or greater than his observed value. Which of the following is a false statement about a standardized value called the z-score? Which one of these is false? The one that is false is C. So standard deviation tells us how far away we are from the mean and whether or not we're below or above the mean. So it will have a positive or negative value as well as a numerical value. What percent of values of the following of a variable following the standard normal distribution is between z-scores of 0 and 3? A z-score of 0 represents an observation equal to the mean, and an z-score of 3 will be at nearly the end of our distribution. So if we're imagining a bell curve, then we have represented nearly 50% of the data because we're starting at the center and covering the entire right side of the distribution. Consider a normal model that describes student scores in a chemistry class. FASA has a standardized score, z-score, of positive 2.5. This means that FASA is 2.5 standard deviations above the average for the class. So choice B. The positive tells us that we're above the above the mean, and the 2.5 tells us how many standard deviations we are above the mean. The end.